Good evening. Welcome to tonight's public information meeting about the Walk Bridge program, and thank you for joining us this evening. My name is Laura Toole. I'm a member of the consultant team retained by the Connecticut Department of Transportation to work on the Walk Bridge program. Tonight's meeting is focused on the alternatives considered for the program as well as the preferred alternative. That's the focus of tonight's meeting. Tonight's meeting is not part of the formal environmental assessment, public hearing, and comment period. That comment period is open until December 9th. We hope if you have not commented but choose to, you do. You can go to the program website, www.walkbridgect.com, and there are many ways to comment. Tonight, as I said, is focused on alternatives and the preferred alternative. So you're going to hear from a number of people as well as have a presentation on the alternatives. And then after that, we'll have ample time to have a conversation about any piece of the program you'd like to talk about, but hopefully focused on alternatives. Thank you. Commissioner Redeker.
Thank you so much for being here tonight. I want to express my appreciation for those who have come and for your interest and your thoughtfulness about this project. The City of Norwalk and all of its stakeholders have been incredibly engaged, and I appreciate that. This is a relatively huge set of investments and program critical for this area, for this corridor, and the number of activities that are planned to make improvements to the transportation network, in particular to the Walk Bridge, really are an amazing set of undertakings, but so critical to our infrastructure and to this region. This meeting really came about after a discussion that took place in the city with state representatives, state senator, the town, the city representatives, and the department, where we were asked if we could hold this session tonight. We presented what you're going to see tonight to those folks, and what they indicated was that a presentation to the public would be incredibly helpful to really get through all of the material that has been produced to get our department to a decision on a preferred alternative that is what the subject of the environmental assessment. So I appreciate you being here and being part of this listening session. We're here to listen, as we have been. And I wanted to just make a few other comments before passing the microphone on. And that is, this is just another session, one of many that has taken place. The DOT team here is embedded in Norwalk with an office. We meet on a routine basis with the city, and it will take all of those efforts and more in our commitment to advance this project successfully. Is part of the region in this actual location. So there are a lot of impacts. There are a lot of parties. There are a lot of communications that have to take place. It's my commitment and that of my team to make this the best example of public participation, engagement, involvement, and communication, and something that will take place over many years and will really be something that I think will be a stellar example of how we will deliver a project committed to outstanding outcomes and to an engagement with our community like no other. So that's our commitment. This is a night to begin a discussion on just one piece of a big puzzle, and that is how do we get to the type of bridge, the alternative that will solve the problem in the best possible way for this set of needs that we have here. So thanks for having us. Thank you for being here, and I'll turn it back to Laura.
First, we're going to hear from some elected officials and then move into the presentation. Mayor Riley?
Thank you so much. The nightmare is when people say you're going to hear from some elected officials. But anyway, the presentation you're about to see tonight was made at City Hall about 3 weeks ago. And I found it to be very, very informative. They're going to talk about the pros and the cons of all the different types of bridges that are under consideration. And I believe you're going to enjoy the presentation. It's got a lot of information. From the city side, I want to ensure everybody that we're doing our due diligence to make sure that the project, as it's being built, is going to have the least impact on our community possible. I'm very concerned about our local business community. I'm very concerned about our tax base. I'm very concerned about a lot of things, and if we're not careful, if we don't work together to minimize those impacts, the results could be catastrophic. So we've hired a consultant from the city side to work on the EIA, to look at it, and we've been assured by the DOT that when the comments are in by December 9th, that they will look at all the comments, they will address all the concerns of all the stakeholders, and have the meetings that will be necessary to make sure that we're going to move forward with as least disruption and inconvenience to the city as possible. So I want to thank the commissioner and his team for being here again. As I said, this is a presentation that we saw about 3 weeks ago. It was really informative, and we came out of there with a clearer understanding of the different types of bridges and the benefits and the downsides of all of them. So thank you very much.
Senator Duff?
Very quickly, just wanted to say hi to everybody and thank you all for coming tonight. And as the mayor said, we did sit through this presentation a few weeks ago, and I want to thank the commissioner and John and his team for coming down and doing this again, because we think that the information that we had is the information that you all should have, and we want to make this as transparent as possible, and that whatever information we have, the public has as well. We certainly know that this is a stressful project for the city. It can be disruptive, and that we want to do everything we can to mitigate that the best that we can while still investing in this regional project. But it is important that we are advocating each and every day for the city in which we live. So we thought that having this information and having the presentation out there, which is very detailed, I wouldn't say it's long, but it's going to really provide each step of the way. That will be very valuable to the members of the community who are interested in this project. So again, thank you all for taking time out of your busy schedules for being here, and we will continue to work together as city and as state officials, along with our partners in the administration and DOT, to help out every place that we can to minimize any disruption impact on the city and businesses. Thank you so much.
Thank you. Representative Wood?
Oh, I'm fine. I'm just going to watch the presentation again. Thank you.
You're welcome. Representative Wilms?
Well, thank you, Laura, and thank you, Commissioner, and everyone from DOT for being here once again. And thank you to everyone here tonight to listen about this very important project. As the mayor and as Senator Duff both said, we had a meeting at City Hall where we were presented a lot of this information. And certainly from my perspective, what I communicated was there's a lot of citizens in Norwalk who are asking or saying, well, why don't we just weld the bridge shut? Why don't we just keep it simple? Why do we have to maybe do a lift bridge? And I mentioned that I felt there was a disconnect between where the engineering was taking the DOT and maybe where we are as a community in terms of this conversation. So this meeting here, I'm hoping, will help to address that gap. I think you should expect that the presentation is going to be technical. It's going to be engineering related, but I think that's probably what we need to hear that critical evaluation. So once again, thank you, and I'll turn it back over to you.
And Representative Lavier?
I get to do it. I get to say Lavielle.
Oh, I'm so sorry.
No, that's all right. It happens all the time. Just very quickly, I also want to thank Commissioner Redeker and the team at the DOT for holding this meeting and for responding to our request that all of you get to hear all of these conclusions. As I understand it, you'll be addressing some of the very questions that people have been asking over and over again, understandably. And I would urge that as the process moves forward, that you continue to hold these meetings and to let folks know that when they give input, what will happen to the input, whether there will be a response to the input, whether it's just to hear or whether it's to incorporate into the project. I think it's a great exercise, and thank you very much. And I think one more thing that I would just mention is that I do hope that going forward, given what we've heard everyone now about the state's budget situation, that the attention to costs on the project will be very close, since we're beginning to have some problems with state debt. So again, thank you very much, and everybody enjoy the presentation.
Are there any other elected officials or their representatives here tonight? Oh, I apologize.
Thank you. I'm Chris Perone, State Representative from East Norwalk. First of all, one thing is clear by the end of this presentation, you're probably going to be the best informed citizens in Norwalk about this bridge. I'm not an engineer, but the funny thing about engineering is one of the most complicated questions you can probably ask an engineer is why. A lot of people are asking why regarding different parts of this project, and it's because it's complex, it's intrusive, it's having an impact on business and also how people move around the city, so that people want to understand how this is going to affect their lives. But more importantly, what I hope to get out of this is improved dialogue with you all, so we understand what it is that's happening, but that we also, and just as a the delegation, legislative delegation, we understand your concerns, because we've heard them. I want to thank Commissioner Rediker for coming, and his team. They've been doing a great job of keeping us informed, but there are clearly still a lot of questions to sift through, and we hope we just get further along in that process. And I thank you for all coming tonight.
So now we're going to begin the presentation with John Hannafin from the Department of Transportation.
Welcome, everybody. So we've been working on this project for a couple years now, and based on asked to come here tonight to explain a few things. So we're going to have a project overview. Then we're going to talk about the alternatives, development, and descriptions. So there's a lot of questions on the alternatives and the preferred alternative that we've chosen. We're going to try to explain those issues and concerns. Then we're going to talk a little bit about regulatory requirements, and then some of the implementation constraints that we have in the project. So as we progress this project along, a number of comments and questions have surfaced, and we decided to come tonight and answer them. They deal with cost, schedule, impacts to the community and the users of the not only the railroad but of the river, criteria, design criteria for the project, and navigation. Like I mentioned earlier, the river is the chief navigation for the city of Norwalk. So Walk Bridge, I think everyone's familiar with the project. It's a critical transportation link right now. It carries the Northeast Corridor. Over 200 trains a day go up and down that line. Almost 125,000 passengers, and its projected ridership will double by 2030. The waterway users. This is a little slide of the river, or a picture. I'm not sure if everyone realizes it, but right now there's over 60 different people, or I won't say people, but facilities that have navigation-dependent uses on this river. This list here identifies 25 on the one column there. I don't expect you to read all that, but maybe with this big screen you can. But this is to show that there's a lot of river use and navigation uses that the city and the surrounding community and the businesses and recreation that depend on this river and their use and every day, but for their livelihoods and for their recreational uses. So one thing we have to come across here for the project that we work with when we set up a project is purpose and need. So people are asked, what is purpose and need? Well, it is the criteria that we use that when we set up a project, it has to be met. So what we decided on this job in consultation with FTA is that we're going to have a resilient bridge. All right? We're going to replace the existing deteriorated bridge with a resilient structure. It has to be a safe and reliable structure. And we want a redundant structure. So what do I mean? What I mean by redundancy is that it'll be a structure that has basically, it's going to be two separate structures. So one moves up and down independently of the other. Currently, right now, the existing swing bridge is a single swing. You lose all four tracks. So by redundancy, we'll be able to still move trains if we have an issue with one of the structures, and you can still move trains. Project goals. As we go through a project, you need to maintain and have project goals. So we have a listing here of project goals. We want a safe and sufficient, we're going to build the project in a safe and sufficient manner in compliance with all environmental requirements that's set up by the feds and the state. We want to continue to have rail service throughout construction, safe and maintainable. We want to maintain navigation and access to the river at all times. And we want to minimize disruption to the community and the local streets and all the businesses around the community. So what we've done over the last 2 years, we put a lot of time planning and engineering into this project. And I'm just going to go through briefly. There's a list of things here, but we started out with a conceptual engineering report back in the mid-2014 into 2015. Then we did an operational analysis of the railroad to make sure we can keep trains moving and keep people moving along their line. We looked at a fixed bridge evaluation. Then we went into we looked at a raised grade evaluation if we were to raise the existing grade of the existing structure. And then we also looked at a rehab of the structure. And we looked at constructability evaluations. So we looked at all the different aspects of the construction on the community and the users. And then we had an addendum to the conceptual engineering report. And then we finished up with our environmental documentation, which is ongoing, the current EA. And we're going to have the comment period that goes out until December the 9th. At this time, I'm going to turn the meeting over to Chris Brown, who's with HNTB, project manager, and he's going to explain more on what we looked at.
Thanks, John. Click this in. So I've been tasked with filling in some of the blanks, answering some of the whys, some of the whats, the what ifs, the hows, and then we'll open it up to questions and answers after the discussion tonight. The Walk Bridge project is a challenge by any definition. We have a busy rail corridor. We have a navigable waterway. We have an interested and dynamic community that wants to be involved. And we're here tonight to, again, fill in some of those blanks. In looking at a bridge project, the first thing that we look at is rehabilitating a bridge. So this structure is 120 years old. So we started off the project in looking at those rehabilitation needs. Then we also looked at what would it take to replace the bridge if the rehabilitation would not be sufficient and could not be completed in a manner that would be satisfactory. We looked at main span types. We looked at different track alignments. So for all intents and purposes, whatever is going to be done with the walk bridge, it's essentially done within the footprint of the existing bridge. So we call that an on alignment or online activity. And there's going to be a number of terms that you hear tonight that you may have heard, and there may be some terms that you may not be familiar with. So if there are any of those terms, please hold those for afterwards, and we'll try to answer those. Railroad operations was a big investigative task that we completed in order to really understand what happens with the railroad. So there are a number of trains per day, and unlike highways, railroads have limited locations where they can change between tracks. There are 2 stations in close proximity to Walk Bridge. We want to be able to try to maintain those station stops throughout whatever improvements take place at Walk Bridge. There are also overhead power lines that cross the water, and those power lines are supported by towers that are about 240 feet tall, and they also need to be investigated to see how they interact with those improvements at Walk Bridge. We have to have an understanding of what's going on in the ground that's supporting the bridge. So there was geotechnical investigation, borings in the water. Some of you may have seen some barge activity last summer where borings were taken so that we could really understand and kind of correlate the information that we had from design plans that were 125 years old. So there's really no record or good record that speaks to what is in the ground. So we need to be able to understand what is down there so that we can assess what has to happen. Looking at traffic impacts, particularly in this instance over North Water Street, and how any construction activity may impact the traffic. Looking at any property needs, and we'll talk about those here in a little bit. The utility impacts also, if we're going into the ground or if there's any overhead utilities that need to be addressed, those all get thrown into the mix. And then what's really driving anything that gets done with Walk Bridge is the construction staging. And what we mean by that is that's that step-by-step implementation plan that will keep rail traffic moving to the greatest extent possible, keep waterway users accommodated to the greatest extent possible, and limit those community impacts. All of the alternatives have gone through an extensive evaluation of that construction staging so that we can identify that step-by-step procedure of implementation and to assess the schedule itself. So when we started looking at alternatives, again, we started with the rehab, right? So everybody is familiar with the existing walk bridge. This image shows the bridge looking to the north, where we've got a couple of spans on the west, then we have the main swing span, and we have a span on the east side of the swing span. So what we did was we first took a look at, well, we didn't want to take a look at any new alignments, right? Because that was really not feasible in our mind, was to build a new bridge, whether it be fixed or movable, on an alignment that was different from where the existing walk bridge was. So we were really confined to those areas of the existing bridge. We also knew that we had to keep traffic running to the greatest extent possible, so we were informed on where we could place new substructure elements. And this image here shows those areas that we kind of categorized on where we could put those different new substructure units, A through E. And those lengths then kind of dictated the type of span and the span length that would be developed from those substructure unit placements. So for example, this image here shows foundations placed at A, B, D, and E. So that main span length here from B to D dictates that span length. And that process was carried out with the other alternatives as well. So that span length was dictated going from A to D. And again, we're trying to miss, to the greatest extent possible, where those existing foundations were. We did evaluate alternatives where there was an existing foundation. It could be done. It's a very cumbersome task to remove entirely that existing substructure unit. These bridges are supported by timber piles that go down about 35 feet into the riverbed. And then also, lastly, here's another example again, going from A to D. So here we had a high-level fixed bridge going from A to D, and here we had a vertical lift span, again, same span length, but trying to miss those existing piers. So that was really the driver behind the types of spans that we looked at, the span lengths, and that then feeds into that overall construction sequencing that we talked about. Through that process, through that iterative process of moving piers from A to B to A to D and A to E and all that permutations, don't try to read that graph that's over on the left-hand side. That's a listing of all those permutations of different structure types, different pier placements, and some of those were ruled out right away because they just were not deemed as feasible from an implementation standpoint. And we'll talk about implementation here in a little bit. But all of those alternatives were really evaluated on a range of criteria, from cost to environmental impacts, construction impacts, meaning like what's happening at North Water Street, what's happening to the railroad, what's happening to the waterway users. And then in the end, we want to have that resilient and redundant structure. We want a structure that promotes enhanced railroad operations. We need to know what the navigation clearances are. And then also this is an opportunity perhaps to maybe bring some aesthetic enhancements to South Norwalk as well. So in the end, some of you may have had an opportunity to review that environmental document and all of the alternatives that are in that environmental document, ranging from the do nothing alternative, which is the no build, ranging from the fixed bridge to the rehab to the movable spans. They're all in that original list of 70. And then as we got into the development further, we actually had subsets of different alternatives, like the fixed bridge had a couple of different subsets. So all these alternatives, that original list of 70 that we call it, were part of that initial evaluation, and those were the ones that kind of rose to the top as best meeting the project goals, best meeting the purpose and need, and really being those that could feasibly be built. So speaking of those alternatives then, that no-build alternative, that establishes the baseline, right? So we have an existing bridge out there. We understand its performance. We understand its characteristics, its deficiencies, all of that. And then we go into those build alternatives. And again, going back to that chart that you saw on the previous page that, of course, you couldn't read, but it's all in there. Those build alternatives include the rehab and then different replacement alternatives for fixed bridges, different arrangements for movable spans, and then out of those assessments came a preferred alternative that we'll talk about here in a minute. And then as I've done before, anytime that you see any of these 3D images and renderings of the different alternatives, just realize that those are conceptual in nature. They're intended to demonstrate the general character of that particular structure type. It's certainly not an indication of what the final structure may look like, but it really speaks to span length, span width, structure type, pier placement, all of those things. And then through that public outreach process that will continue after tonight, including tonight, that really is going to dictate what that new structure or what that rehabilitation structure looks like. So that's the structure side, that's the bridge side of the alternatives development and looking at bridge types and structures. We can't forget that we have an existing movable span there, which tells us that we have a navigable waterway. There's an existing Coast Guard regulation that's in place now. By virtue of that, it is a navigable waterway. The Coast Guard has jurisdiction over that. So we looked at the maritime user needs, and through a navigation study, developing those reasonable needs of navigation that were developed through consultation with waterway users, with the United States Coast Guard, with the Corps of Engineers, with Connecticut DEEP, looking at channel alignment. A lot of times what we see on these swing spans, these old swing spans, keep in mind, at the turn of the last century, swing spans were the state of the art, okay? And different movable span types didn't really start to surface until you got into the 20th century. And a swing span at the time was great, and it was an efficient structure. And the thing that it also has is it has this big pier protection system that protrudes in and out from the structure itself, which a lot of times actually causes a little bit of hindrance to navigation. And then when you couple that with a structure that is in close proximity to that, it can sometimes make navigation along that waterway a little bit challenging at times. So we wanted to look at a way to investigate whether there was an opportunity to improve the channel navigation in this area as well. Also, with barge traffic on the waterway, we needed to be able to understand what type of vessels were out there, what type of tonnage those barges do carry, and look at how to protect any substructure, whether it be the existing substructure or any new substructure, so that the integrity of the bridge remains intact should a vessel collision of that structure occur. And then also we need to understand what's happening with the waterway itself. So we do have an understanding of what's going on out there now because of the hydraulics that are on the channel. But if we change that configuration of the channel, if we start to introduce new piers, or if we open up the channel, or if we constrict the channel further, we need to understand what is happening along the waterway. And all that's investigated as part of a navigation study and our hydraulic analysis. There's been a lot of focus, particularly in the environmental document, and rightly so, on the regulatory requirements that have to be met as it relates to the project, but really from an engineering perspective. So I'm a bridge engineer, and I like to see these problems solved and figure out how to build these projects. And what it comes down to a lot of times in our decision making is how do you actually implement any improvements here? Whether you're rehabbing the structure or whether you're going to be putting in a new structure, you have to figure out how do you keep trains moving, how can you keep the waterway open, how can you limit impacts to adjacent properties and other community impacts. And one way that we do that is we want to utilize and we want to leverage what we call accelerated bridge techniques, accelerated bridge construction, or ABC. And those ABC techniques are really what's going to drive the schedule on anything that gets done with Walk Bridge, because we understand that schedule is a big concern to a lot of you. And what we want to do, as John mentioned, we want to complete the improvements at Walk Bridge safely and in an efficient manner. And an efficiency means how can we do it as quickly as we can without compromising or cutting corners. So those ABC techniques are really what's going to be driving a lot of our decisions. There are a number of construction constraints related to this project. This is probably one of the most congested sites that I've personally been involved with. There are adjacent properties on the west end of the project. There's adjacent properties on the east end of the project. There are upwards of 200 trains a day that travel along this corridor, and those trains, the passenger trains on the New Haven line, are all powered by overhead electrification. And that's something that has to be taken into consideration in looking at how efficient you can perform any improvements at Walk Bridge. There's also Metro North and FRA, Federal Railroad Administration, operating rules that not only protect the traveling public and the local public, but it also protects what they call the roadway workers. Those are the individuals, those are the construction workers that are going to be on site, operating equipment, working from in close proximity to the existing tracks. So all of those things come into play on how efficiently and how quickly any of these improvements can be implemented. So all of those constraints, they affect the safety, they affect the risk, the cost, and the schedule of any of the improvements. And really, each of these alternatives is unique in that they all address those constraints in their own particular way. Some address those constraints better than others, and we'll talk about that. And then in the end, what we want to have, and this has been discussed, is that we want to have a set of mitigation plans in place, construction mitigation plans, whether they be environmentally related or public outreach, business communication plans, et cetera. Have all those mitigation plans, because as you'll see, all of these alternatives really have similar impacts. So take, for example, this image that we see here as it relates to working safely around railroad. This is a cross-section, just a sliver cut through the existing bridge at a point close to the IMAX where we're standing today, and we're looking to the west. And let's say that we wanted to install a new foundation element. We have a little drill rig that's shown here, and we're kind of augering into the ground a little bit. And when you're working in close proximity to the railroad tracks, that's where those Metro North rules and those FRA rules really kick in. And it doesn't seem intuitive, but your opportunity to do work when you're very close to the operating railroad is very limited. Sometimes that limitation is to brief periods, and those brief periods can be at night. Say, for example, and we've experienced this when we've been taking geotechnical borings. We'll get a track at 1 a.m. That's at least the time that we're told that we will get the track. But because of train schedules and because of other constraints on the railroad, we may not be able to start our work until 2:30 in the morning. And then we have to get off the tracks at 4:30. So that work window, which is the time that you have to do any operation that's close to your operating tracks, gets shrunk from, say, 8 hours to 2 hours. So if you had an 8-hour operation planned and you're only down to 2 hours, that 8-hour operation now became 4 times longer. So that's what we talk about, schedule risk and cost risk when we're working really close to the railroad. And just moving away from the railroad, even 15 more feet or 25 more feet, you can kind of work almost free and clear. So you're not bound by those FRA rules or Metro North rules, so that efficiency kind of kicks up. And so when you look at some of these alternatives, for example, some of the fixed bridge alternatives versus some of the other alternatives where you're getting further away from the operating railroad, that drives the schedule, that improves the schedule. And so that, again, is driving a lot of our decisions on the layouts and the configurations of the different alternatives. We talked about property needs, and there are property needs that are needed in order to implement these improvements at Walk Bridge. It comes down to access. You have to be able to access the work that you're doing. And ideally, you can access that work where the activity is actually being performed. So if there's retaining wall work, you want to be able to get right up next to where you're working on the retaining walls. Obviously, work over the waterway will be done by a floating platform, but there are construction or temporary easements and permanent easements as shown on the map here. And it all comes down to being able to, again, leverage that schedule and to improve on the access to where the work is being done. Also, some of these property needs as part of the project are really there to leverage those ABC, accelerated bridge construction techniques. We want to be able to pre-assemble as many things as possible close by to the bridge so that when it comes time to install those elements, they can be done in a swift and efficient manner, again, compressing the schedule. So a lot of those property needs are there in order to leverage those ABC techniques. And the important thing to remember here is that whether it's an access constraint or whether it's a desire to implement ABC techniques, all of the property needs, rehab, fixed bridge, movable bridge, with the exception of the high-level fixed bridge, all of the property needs for these alternatives are consistent. Now, some of the property may be a little bit more congested during construction than others, just because of volume of materials, steel and concrete and reinforcing steel and all of that. But all of the property that's shown, you don't get a break, whether you're going with a low-level fixed bridge or a rolling bascule bridge. The project limits between the movable and the fixed bridges, just like the actual temporary and permanent construction property needs, those project limits are the same, nearly the same, for all the alternatives as well. And I have to caveat this again, all of the needs from the project limits and the property needs, they're consistent for all the alternatives with the exception of the no build, because if you don't build anything, you don't need anything, or the high-level fixed bridge, which is in a completely different category in and of itself. But when you look at the other two fixed bridges and you look at the movable spans, the project limits are nearly the same, as well as the rehab. So they do differ. The implementation of the west portion of the project also is the same in terms of the project limits for all of the alternatives. So if you have a low-level fixed bridge or you have a rolling bascule bridge or you're rehabbing the structure, all of that same type of activity and the work zones are the same. You still have to do the work at North Water Street. You still have to do the work in the area by the aquarium. So you really don't get a relaxation. But what you do get a relaxation of is in terms of schedule, in terms of the impacts to North Water Street, for example, with the different alternatives. And it all, again, comes down to how do you stage it? How do you implement it? How do you keep the trains moving and stay away from the operating tracks in order to make that happen? So again, looking at an aerial here, some of you may have seen this before, but we've compartmentalized the project where we have work done on the east approaches, the east structure, the main span, the west approach structure, and then the west approach. So for all the alternatives, we're doing work in all of those areas. If we're rehabbing the project, we're rehabbing the high towers on the east side. If we're replacing the bridge, we're still going to be doing work over North Water Street and on those west retaining walls. So again, there's really no difference in those alternatives on the west approach in particular and on the west approach structure. It's all a matter of How do you address it? How do you limit the impacts? And how do you implement those necessary improvements? So let's talk a little bit about some regulatory aspects. We're not going to get really into a lot of detail on the regulatory, but a lot of the agencies that have been coordinated with are listed here. The United States Coast Guard is paramount in this entire process. As it is right now, the Norwalk River is a navigable waterway, and the Coast Guard is involved. And some of you may have a question, well, why is the Coast Guard involved? And the Coast Guard, as part of Homeland Security, does many wonderful things, right? They do marine safety and law enforcement, and they have navigations. And what they also do is that they administer bridges. So bridges that cross a navigable waterway are administered by the Coast Guard. And what the Coast Guard does in terms of that bridge administration is that they have to approve the locations and plans for any bridge that crosses a navigable waterway. And what they also do, and what they do right now, I mentioned that there's a regulation, a Coast Guard regulation on the existing span. They also regulate drawbridge operations, and again, their goal is to balance land and marine transportation needs. One added thing that they do is that they will also tell an owner that if you have a bridge that unreasonably obstructs navigation, you have to remove it. Now, the good thing about that, that's part of the Truman-Hobbs Act, the good thing about that is that the Coast Guard will actually pay the owner to replace it, or a portion of it, but that's kind of how they view bridges. The Coast Guard views bridges as obstructions. And I'm not going to get into all these federal regulations and statutes. Like I said, I'm an engineer, and I've applied these in practice, and I'm not an attorney, but there are a number of federal laws and regulations that the Coast Guard abides by in their operations. So let's look at the Coast Guard mission statement, and really what they're aimed at as part of that bridge administration is to protect the freedom of navigation and the quality of the environment, and to ensure a balanced approach to land and transportation systems. So they get it. They understand that, look, we've got a roadway or we have a railroad that needs to get across a waterway, but we also may have some vessels that use that waterway as well. So how can we kind of strike a balance between providing that surface transportation, in this case rail, and the waterway users, right? And one way is to establish those navigation clearances. But the Coast Guard does view bridges as obstructions to navigation and are permitted only as long as they serve the needs of land transportation while allowing for the reasonable needs of navigation. And that's really the key here, is the reasonable needs of navigation. So there's no federal mandate that says you have to provide unlimited navigation. If there weren't any overhead power lines right at Walk Bridge right now, that swing span, by how it operates, provides unlimited vertical clearance. So if you had a 203-foot tall vessel coming through here, they would only be bound by those overhead power lines. So it's not an absolute, but it's the reasonable needs of navigation. What kind of navigation is out there today? What navigation has been out there in the past, may come back, or what type of navigation is going to be out there in the future? That's what they look at. So in looking at the definition of a navigable waterway at Walk Bridge itself, in the definition from the Code of Federal Regulations, that's what CFR is, they are internal waters of the U.S. that are subject to tidal influence. So that's what we have at the Norwalk River, and it's designated as a navigable waterway. The image over on the right is just a snapshot of the NOAA navigation chart that has the Norwalk River listed and lists the bridge clearances and everything like that. So paramount to our alternatives development is to understand what navigation clearances are needed and what those reasonable needs of navigation are, so that when presented to the Coast Guard, they can make an educated decision. Now, that being said, they already kind of have an educated foundation of the type of navigation on the Norwalk River, the type of operation that the existing span has experienced as of late. So they already have an understanding. But as part of our process, what we do is we communicate with waterway users. We understand what type of vessels they have, what type of frequency that they have, in order to establish what those reasonable navigation clearances are. So we're looking at what future navigation could be out there, that historic and existing navigation, talking to the waterway users, looking at what's going on as part of a federal navigation project, i.e. dredging, things of that nature. So in answering some of those questions then, or some of the questions that do get asked by the Coast Guard, of a bridge. So when we go to submit a Coast Guard bridge permit application, which, by the way, we're kind of early on in this whole environmental process, right? We're just in the EIE phase. There's a whole permitting phase that happens after the fact. And the last permit that gets approved is the Coast Guard bridge permit when you're looking to build a structure over a navigable waterway, okay? So we're going to have a lot of dialogue with a lot of different agencies, Fish and Wildlife, Connecticut DEP, Army Corps, etc. But at the end of the day, it's the Coast Guard that before any shovel can go into the ground, they have to issue a Coast Guard bridge permit. So they want to know how that bridge is going to obstruct or not obstruct those reasonable needs of navigation. Does it impact present or potential commercial navigation? Does it impact dredging? Does it match the navigation clearances that may be on that waterway right now? So the Coast Guard doesn't care about the overhead lines. I mean, they care about it, but the overhead lines get permitted separately. So there's a lot of clearance there now. They're focused on what piece of that bridge is going to be an obstruction potentially. So what the Coast Guard does is that they develop guide clearances for waterways. And those guide clearances are generally set by structures that are already out there. And they take a look at those structures that are out there, and they recognize that are there vessels that are accommodated by a structure or an obstruction, as the case may be, in establishing those navigation clearances. Because they realize that, any decision that gets made for those navigation clearances, you're pretty much locked into that for 50 or 100 years or more. In the case of Walk Bridge, we're looking at 120 years. So this is really a century-long decision that has to get made, and the Coast Guard wants to ensure that right navigation clearance does get made. So those are the federal requirements as it relates to a navigable waterway, but there's also state and local requirements that have to be met, particularly the Connecticut DEP and the Office of Long Island Sound Programs, in looking at the Connecticut Coastal Management Act. Our friends from the Norwalk Harbor Management Commission also have goals and plans for the waterway itself. So all of those federal requirements do kind of trickle down to the state and the local level as well, all speaking to what type of navigation is needed, what type of navigation clearance does that bridge have to accommodate. Can an existing movable span be converted to a fixed bridge, whether it be the existing structure or with the new structure? And the answer is yes, and it does happen. The pictures of the three bridges that you see here, those are all either plans on the shelf or under design right now. These are projects that I personally have had involvement with. Two of them are on the Northeast Corridor, just like the Walk Bridge, Amtrak's Susquehanna River Bridge, and the New Jersey Transit and Amtrak Portal Bridge. Those are all going from a swing bridge, just like what we have at Walk Bridge, to a high-level fixed bridge, or a higher-level fixed bridge that matches navigation clearances in the surrounding area so that they don't unreasonably impede navigation. What's very different about these projects is two things. One, they are built on a new alignment because they're really long bridges, and there's the room to accommodate building a new bridge on a new alignment. So we're not trying to build a bridge on top of an existing bridge. The second thing is that they are really long. And because they are really long, railroad grades are different than highway grades. So a highway, if you approach a steep grade, you can get up and you can get down with relative ease. But on a railroad, that's not the case. And there's limitations on how fast you can go uphill and how fast you can go downhill. And these 3 bridges can accommodate that. Unlike Walk Bridge, a high-level fixed bridge we'll talk about, but it doesn't really apply here. So the 4th bridge that I have listed there is actually a highway bridge. That's down in southern Louisiana that was impacted by a hurricane, but that was a movable span that was replaced or is scheduled to be replaced with a high-level fixed bridge. So it does happen, but at the root of this is that the navigation clearances that were presently accommodated by the existing span are met by that higher level fixed bridge. So let's get into the alternatives here. And again, looking at the no build and the build alternatives, and then we'll talk about the preferred alternative. So since we have an existing swing span there, one departure from what we would typically do on a project like this is that we introduced 2 other types of fixed bridge alternatives into the discussion. And we did that because we heard questions from all of you on why don't we do a low-level fixed bridge, or why don't we try to raise the grade of the existing tracks a little bit and still try to accommodate those waterway users. That we've done in the case of an existing movable bridge, and we'll talk about that here in a second. But the low-level fixed bridge is a bit of a departure from what you would typically see, where you have a navigable waterway that's active with recreation and with commerce, and put in a low-level fixed bridge. But we did that, again, as part of our fixed bridge study, again, to address some of the questions that the public did have. So when you stack all those alternatives up against one another and you look at the different project needs that were listed, whether it relate to reliability and resiliency, all the way down to sustainability, you'll see a lot of checks, which is good, and you'll see a lot of X's, which indicates that that particular need is not met by that alternative. So across the top, we have the alternatives listed: rehab, low-level fixed bridge, the mid-level fixed bridge, high-level fixed bridge, and the movable bridge. So the movable bridges are kind of lumped together because of their nature. Now, there's different types of spans that we looked at, obviously, and different span lengths, but they were all kind of lumped together. But we wanted to separate out the low-level and the mid-level fixed bridges so that you could kind of see the different attributes of that. And what those 2 bridges come down to really is how those bridges get implemented and part of that construction staging. You will see 2 X's under the marine capacity and dependability under the low-level and the mid-level fixed bridge. And again, that was, in our view and in our assessment, and through consultation with waterway users and consultation with the U.S. Coast Guard, that those 2 bridges, because of their vertical navigation clearance, they didn't meet the reasonable needs of navigation. So let's look at the no-build alternative here. And the no-build alternative is, again, that's that baseline, right? So we have to understand what the issues are. And I think the issues are pretty well documented as it relates to either the span not opening or the span not closing, or the span not opening when it needed to open. It eventually opens. But there's a lot of areas of that existing structure that need to be addressed. And that's just by virtue of the fact that it's 120 years old. Quite frankly, we are literally in uncharted waters when it comes to a bridge of this type, on this type of corridor, of this age, and still out there today. Now, not to sound any alarms at all, so the bridge is not, in any danger of imminent collapse or anything like that, but there is a little bit of an accelerated deterioration that's going on, and that's just because it's 120 years old. There's really no way around that. So we want to improve the safety standards on the bridge, the sustainability, and we want to really cut down on the maintenance. The state spends a lot of money each year on maintaining an old bridge. They would spend a lot of money maintaining any old bridge, and they do. And if there's a way to kind of cut back on that yearly expenditure of maintenance, that would be of interest to a lot of people. So in looking at those deficiencies then, we had to study those areas of deficiencies and identify areas of improvement, whether it be strengthening different members or replacing different members, kind of breathing new life into that existing structure. And again, a lot of the information that we rely upon are detailed inspections that we conduct ourselves, analytical calculations, previous inspection reports, previous studies, and those great old 1994 plans of the existing bridge. So that's the no build. So if we just walked away from the bridge and we said, all right, there it is, we'll just kind of deal with all of those deficiencies, and then we'll make those maintenance repairs along the way. That rehab alternative then is kind of that no-build alternative morphing into something more. So now we actually want to take those areas of deficiencies and make the improvements, okay? The thing to keep in mind on the rehab alternative is this is the alternative where, for all intents and purposes, you don't really have a choice but working in close proximity to the operating railroad. And because of that, because of the type of work that has to be done, your ability to do that work, or those work windows, shrinks. And when you shrink your work window, you're prolonging the construction schedule. There's just no way around it. In order to keep 150 trains going a day, you're going to be working in between trains, you're going to be working at night, and that just really draws out the schedule. When you draw out the schedule, what does that do? It draws out the cost of the project. So in looking at the rehabilitation, if you look at the image on the bottom, let me see if, hopefully everybody can read that, but it's a system-wide rehabilitation. Okay, so it's not kind of piecemeal, hey, something broke here or something doesn't look right there. It's taking a holistic look at the entire structure, figuring out what has to be done, and then making those improvements. And there's really nothing immune on this structure, again, just because of its age. It's a great bridge, but because of its age, there is work that has to be done, and it runs from east to west. There's a lot of work that has to be done on those west approaches over North Water Street, a lot of work on the main span. It has to be painted. The high towers need to be rehabbed as well. The foundations need work. If we take a look at the superstructure itself, the image on the upper left is a typical approach span. We showed the span over North Water Street. On the next slide, the items that are highlighted in yellow indicate those items that need serious consideration for being replaced. So you're going to kind of be unzipping this truss that has been kind of happy for 120 years and start to introduce new members because they presently don't have the load carrying capacity per se. They have excessive deterioration, or they may have some fatigue issues that need to be addressed. The same thing happens on the swing span itself. A number of members on that span have to be replaced. And so from an engineering perspective, this takes a lot of work because every single detail, every single rivet hole, all that stuff has to be known. You have to know all the dimensions. You have to go out and field measure everything. Everything has to fit up. And you're doing it while you're running 150 trains a day overhead. So again, schedule going out because of that complex operation. There's upwards of 5,000 main carrying members on this entire bridge. And you can see the ones in yellow need those improvements. Let's talk about redundancy and resiliency. So redundancy is really that operational redundancy. And you know, those engineers back in the 1890s, they were pretty clever. They came up with this unique swing span. Let's put all 4 tracks on the same swing span. And everybody said, yes, engineering marvel. Well, 120 years later, when it comes time to try to address what's going on with that span, that's actually probably the biggest constraint that we have on the project, is the fact that that truss carries all 4 tracks. It doesn't offer that redundancy that we're looking for, so that when maintenance does have to happen, think about it as your car. Whether it's a movable span or not, bridges need maintenance. They're exposed to the elements. They're exposed to wear and tear. There has to be routine, periodic maintenance that occurs. So we're not getting away from a maintenance-free bridge. But that redundancy kicks in when you have to take tracks out of service to do that maintenance. And on this particular structure, it doesn't have that redundancy to address those needs. So what happens then? Train delays or a longer construction schedule. Cranes are going to be out there longer because, again, your ability to do the work is confined by your train schedule. Also, resiliency, and how we define resiliency is the ability to return the bridge to use, either partially or completely, in a relatively short period of time in the aftermath of a compromising event. That can mean nearly anything. It also refers to minimizing the vulnerability of critical elements of the bridge in order to facilitate its return to use. So resiliency a lot of times comes down to, in this case in particular, comes down to storm surge and inundation, right? So if we have an extreme storm event and there's a storm surge or there's a flood, we want to be able to ensure that any alternative is resilient. There's also fracture and fatigue resistance and vessel collision, seismic resistance. Overall integrity of the structure leads it to be resilient. So it's not just that inundation aspect of it. So the existing bridge itself has a design flood elevation of elevation 15. And so we're kind of right on the cusp of getting those critical operating elements exposed to inundation from the federally mandated flood elevation, which is the 100-year flood plus 3 feet. It doesn't include climate change. It does include climate change effects, but it doesn't include storm surge. So when we talk about storm surge then, so this is just if you had a flood event. If you had a hurricane event, that storm surge then goes up to elevation 24.4. Where does that number come from? Well, the National Oceanography and Aeronautics Association, NOAA, they have storm surge modeling for Long Island Sound already done. So we're able to communicate with them and know what that storm surge elevation is. So from an inundation standpoint, we want to keep everything above that elevation. Unfortunately, the existing swing span doesn't accommodate that. Those elevations does not include a parameter for sea level rise. So when you take that into consideration, that elevation has to kick up even higher. So the rehab alternative, there's an accelerated rate of deterioration. You know, one thing when we get into rehabs, and we do rehab bridges all the time, and one thing that you can count on for sure is that you're going to come across something that you didn't plan for. So again, when we're relying on inspections and existing plan information, there's likely going to be something that doesn't look right or something doesn't fit. So that's one of those schedule risks that we have. There's the case here where we're going to be repairing stuff that's already been repaired once, maybe twice or more. The extent of the repairs and the high rate of deterioration and all of those repetitive cycles of the maintenance on the bridge that go up really only make it possible to do that full system-wide rehabilitation. And I know that there's some question about, well, why don't we just lock down the bridge and not make it movable anymore? Well, doing that doesn't address everything on the bridge that needs to be done. And quite frankly, the movable bridge aspects of this existing swing span make up a small fraction of the total cost of addressing all of the needs on the project itself. And one of the things that is really tricky with an old railroad bridge is that you're mixing an old infrastructure. So we can make all these improvements, we can strengthen the foundations, and we can do all that. But at the end of the day, we still have this old bridge, and we're trying to run this modern rail system on top of it. And the two don't always mesh all that well, because back when this bridge was designed, they didn't have catenary, they didn't have continuously welded rail and other rail features that we have out there today. So there's always not a good match when that happens, when you have an old structure with those modern rail systems. So again, with the rehab option, you have a lot of train impacts, marine impacts, there's cost risk, and there's schedule risk. We'll talk about the runaround here, because one of the ways that we're looking at implementing rehabilitation efforts is to implement a runaround. Again, we want to try to get away from the operating tracks as much as we can, right? And one way to do that would be this runaround. And a runaround, now we're going to kind of shift our perspective here, and we're going to look to the southeast at the existing bridge. So the runaround itself is a temporary fixed bridge that would be implemented, and it would peel off on the east side, cross the river, and then get tied into the existing bridge. Now, that accommodates about 85% of the total bridge length, but because of our constraints based on the adjacent properties, we can't bypass the entire bridge. So we're left with the ability to clear the swing span and the east approaches, but we can't clear the west approaches. We can't clear what's happening at North Water Street. The runaround crosses over North Water Street, and there's actually a lot of prep time that takes place in order to actually implement this temporary bridge. So we're building a bridge so that we can fix the existing bridge or to build some of the other alternatives. And again, the whole idea is to do it safely, to get away from the operating railroad as much as we can, and to do it in an efficient manner. What it does do is that it places this temporary structure in really close proximity to the aquarium. I mean, I'm talking literally inches away from the aquarium. That's how tight that is. It does have some risk associated with adding foundations adjacent to those existing buildings, to the existing bridge itself. We do want to have a ballast deck because the curvature on this bridge is such that every time a train passes, you're going to have that rail squeal or that noise of a train going across a tight curve. The ballast deck helps with that, but what it does is it makes the foundations bigger. And what that does is it increases our environmental footprint. So this is one approach to do this, whether it be the rehab option or some of the fixed bridge options. And then also from a railroad operation standpoint, because of the physical constraints on our ability to shoehorn this bridge into the site, the train speeds are going at 15 miles an hour. They now cross the bridge around 45, 50 miles an hour. So now you're going to be taking 150 trains a day and slowing them all down to about 15 miles an hour. So there's a lot of train impacts to that. The high-level fixed bridge, in looking at the existing swing span above mean high water, there's about 16 feet of clearance there over the waterway when the span's in the closed position. With the high-level fixed bridge, using the guide clearances provided by the Coast Guard for the I-95 bridge, results in a structure at 60 feet clearance. So that meets the reasonable needs of navigation. That's great. What that also does is that it has dire impacts to the city of Norwalk for this particular alternative. And what I mean by that is that you basically have this large structure now passing right through East Norwalk and through South Norwalk. Those railroad grades are capped at the 1% grade that we see here on the image there. And the limits of the project, this is where we talk about the difference of the limits of the project, go all the way from East Norwalk Station, and because of those railroad grades, we can't get up and down fast enough to hit South Norwalk Station. So it would require a new South Norwalk Station. It does meet that purpose and need, but it also is the most costly, and it's also the most environmentally impactful of all the alternatives. So let's go on to those other fixed bridge alternatives. And again, these two alternatives were introduced by virtue of our communications and the comments that we've received from all of you. Why can't we have a low-level fixed bridge? So when you take a look at that low-level fixed bridge, the bridge is flat right now, pretty much across the existing structure, and the bridge is pretty happy without having any grade on the existing bridge itself. And again, it provides 16 feet of vertical clearance when the span is in the closed position. With a different type of structure and with modern current day construction techniques, we can increase that navigation clearance with a fixed bridge to 20 feet. 20 feet does not meet the reasonable needs of navigation based on current waterway use. It doesn't meet reasonable needs of navigation based on historic and potentially future waterway use as well. But that's the regulatory side of it. Let's talk about the implementation side of it. This is where, again, working close to the operating tracks, because again, we're building this bridge right in the footprint of the existing bridge, so we have to stage it right. And the way to stage it is potentially to incorporate that runaround structure. Well, if we had a runaround with this bridge, that'd be no big deal, right? Because we're already providing an obstruction with the finished bridge. So there's no big deal of having an obstruction with a runaround. However, there are some constraints that do come along with that. And again, if you look at this bridge from a cost perspective, and those costs are the costs that you've seen, you know, if we had a clean slate that we could start with, and we said, let's just cross the river, and let's not give any consideration to any of the regulatory requirements, then yeah, that low-level fixed bridge seems to be one of the ways to go. But you got to remember that you have a bridge there now, and you got to keep those trains going, and you're working in close proximity to the operating railroad in doing so, introducing a runaround, which thereby increases that environmental footprint over the others. So with that, you know, you have the resilient structure, you have improved reliability for rail traffic because you have this brand new bridge. It doesn't meet navigation, the reasonable needs of navigation. You do have that temporary runaround structure again to try to move the construction along a little bit more efficiently. And because we're working in close proximity to the tracks, you've got high schedule risk and cost risk, and now all the other impacts to the traveling public as well with the low-level fixed bridge alternative. And when we look at costs, one thing to keep in mind about the costs, it doesn't reflect those cost risks. So cost uncertainty is a big thing. So as engineers, when we look at cost, what we're doing is we're taking, okay, we have a certain amount of concrete, we have a certain amount of steel, and we kind of know what those unit prices of each of the elements are, and we develop the cost. But what it doesn't do is what happens when we have a work window that shrinks from 8 hours to an hour and a half. What does that do to the cost? And that drives up the cost. So mid-level fixed bridge then. We're getting pretty close to the end here, folks. The mid-level fixed bridge actually was a byproduct of what we looked at on a movable span option. So what we did at Niantic, up the road a ways, was on the Niantic River Bridge, what we developed was a grade raise on the movable span. So there's still a movable span with the new bridge at Niantic, but that was built on an entirely new alignment. We had the real estate to accommodate that, and we could increase the grade at that particular bridge. But what we did do is we took a look at the snapshot of navigation use that we had available to us, and we took a look at, well, what happens if we were able to accommodate the barge traffic, okay? And by doing that, there may be an opportunity to eliminate a number of the openings on a movable span. That then turned into, well, let's turn that grade raise into the mid-level fixed bridge. So we're going to kind of nominally increase the track elevation upwards so that we can try to increase the bottom chord of the bridge itself, and that distance from waterline to low chord would go up. So with that, we could have a structure that has upwards of 34 feet of clearance. So we're going from 16 feet to 34 feet. But the thing to remember here is that this waterway is subject to tidal influx, right? And there's a big swing between the water elevations, so there's no guarantee that those commercial vessels could be accommodated. They wouldn't have necessarily free reign on that waterway. So the fixed bridge alternative as well has some constraints, just as the other alternatives do, that we talked about. But if we take a look at the image here, so on the east side of the project, we're going to be slowly going up as we approach the waterway, and then the same thing on the west side of the project as well. We're going to increase the grade at 1%, because that's really the maximum that we could do. So if you stand on the walk bridge and you look down towards the west, you can just see a maze of overhead catenary and the rail systems and the structure itself, and it's a really complex endeavor to try to improve that track profile. The key challenge here is in that area over here on the west side, where we're really kind of shoehorned in between the ironworks building and the lock building, and how do you increase that grade raise, or how do you increase that grade? So the mid-level fixed bridge then, if you took a look and you stood in the parking garage at Ironworks and you looked at that high tower, at the high tower itself, you're looking at about a 6-foot increase, okay, and then it tapers down before it gets to the Danbury line. Looking down the alleyway between the walls and the ironworks is very tight. There's not a lot of room to operate. And then on the right-hand side of the slide, you see the alleyway between the lock building and the retaining walls. So again, there's really tight confinement in that area. So what we're looking at doing then, again, if we cut a sliver through the bridge itself, this is just beyond the west abutment looking to the west, okay? So those little black dots on top represent the catenary, and we got trains on there. And what we want to be able to do then is we want to increase that grade, that 6 feet. So at that location, you're going to be 6 feet taller than what you are today. It doesn't sound like much. It's a little shorter than I am. But when you're talking about increasing the track profile that much, it's pretty significant. And it represents a lot of challenges. And again, we want to keep all of the work within the existing right-of-way, the permanent construction within the existing right-of-way, represented by those red lines. So we've looked at, and we have studied this a lot, I can tell you that. And one alternative would be to add more height to the existing walls. Well, those walls are very challenging. They have a lot of unknown conditions to them, and adding any new height or load to them would be a challenge. We looked at building a bridge and even walls within the walls to try to retain this height, this extra 6 feet that we're trying to accommodate. And really what kind of ruled this out, in fact, we have an entire 30% design of this done, and it has a fatal flaw in that when you get to this condition, so imagine you're looking at the 2 tracks on the left. So those are under construction right now because we're working to raise that grade 6 feet, and we're operating on the tracks to the right. At this location, you can only operate 1 track. So now, we're, like that runaround bridge had 2 tracks, and we're trying to get 150 trains a day on 2 tracks. Now we're trying to get 150 trains a day on 1 track. A lot of schedule impacts on the commuters with that operation. So really, the mid-level fixed bridge, while it's attractive in terms of its ability to accommodate navigation, its challenges in implementing really kind of ruled it out. And I'm going to skip this slide because it's hard to tell what's going on there. So again, the mid-level fixed bridge where we raise the grade, we say it doesn't meet the reasonable needs of navigation because there are vessels that cannot pass beneath 34 feet. We would implement that temporary runaround, and the grade raise on the west approach is really challenging, and it has a lot of risk associated with cost and schedule because you're doing all that work right there at North Water Street to try to raise that grade. So now we move on to the movable bridge alternatives. And again, that list of 70 bridges that we saw, probably 60 or so of those alternatives were different movable bridge types, whether they be bascule bridges or vertical lift bridges. And the movable bridge alternatives were the lowest cost to satisfy the purpose and need. If you remember, the only other alternative that met the purpose and need by the definition of the project was the high-level fixed bridge, and that was the project or the alternative that had the highest cost. The movable bridge alternative would be resilient to extreme weather conditions because we would place all of the equipment where it would need to be placed such that it wouldn't be subject to inundation. It would be resilient to seismic, to long-term fatigue, and vessel collision. There's also the fewest foundations in the river itself. It has the potential for the shortest construction schedule. It also has the shortest duration of when we would have to go down to 2 tracks, which is also attractive. And we don't have to have the temporary runaround here because the way that we're configuring the structure type and the way that we're configuring the foundations, we have the ability to get far away from the operating railroad to make construction really efficient. So those 3 alternatives, as it relates to addressing the project's needs, kind of rose to the top. So then what what we had to do, and this is what was presented in the EA, was what's the preferred alternative, and why is it the preferred alternative? And in the images that you see here, we have the 240-foot vertical lift span as the preferred alternative. Some of the benefits of that alternative is that it has the shortest construction schedule of all the alternatives. I know that sounds counterintuitive, that you have this big bridge. How in the world does that have the shortest schedule? Well, we have the fewest piers in the waterway. We get to pre-assemble virtually all of the new structure off-site and have it ready to go for installation. So those are some of the things that contribute to it having the shortest construction schedule. And it also has the shortest duration of that 2-track outage. Again, that 4-track swing span is the big impediment here when it comes time to talk about overall staging and overall rail impacts. And because we have the span of the proposed bridge, of the preferred alternative, longer than the existing swing span, we don't have to deal with the swing span. We can keep the swing span operational. It can open and close. We don't have to deal with it during the construction. So that's one great thing about this particular alternative. Fewest foundations in the water itself, so it has the smallest environmental footprint when we want to talk about what's going on in the water itself because of the few number of foundations. And we're opening up the channel. So any safety concerns that's out there from the maritime users because of that narrow channel with the swing span and the shear fence coming in and out of the bridge, that goes away, and we get better alignment with the Straffolino Bridge. And this alternative also offers opportunities for what we call architectural and aesthetic flexibility. So what that means is that there's a number of elements, a part of that structure that are subject to public input, whether it be lighting, whether it be color, whether it be the configuration, kind of developing an overall theme for what could be an iconic structure for the city of Norwalk. So again, it does provide that aesthetic flexibility with the truss and the tower configurations, control house, and other features to really make those improvements in that short schedule that we're talking about. We do get questions about, how tall are the towers? We're looking at a range. We're probably on the upper end, closer to 115 feet. How does that compare to the high towers? It's about half of the high tower height. So again, there's vertical elements at either end of the bridge right now. These high towers could potentially replicate those vertical elements across the landscape. And then we also get questions about, well, how much does the movable bridge piece of the bridge cost? So if we were to just take that 240-foot long lift span and not put mechanical, electrical systems and not put the lift span towers on it and the counterweight and all of that, and had a span that was 240 feet long and did everything else that we're going to do, it's about 10 to 15% of the cost of that was shown for that alternative is comprised of the movable bridge elements. So it's a pretty small, relatively small portion of the total project cost is made up with the movable bridge features. And then in a comparison between the different fixed bridges and the preferred alternatives, we kind of use a little traffic light scenario here where red is kind of a disadvantage and green is an advantage as it relates to construction duration. And this is kind of predictable construction duration and doesn't really take into consideration construction risk, as well as the local impacts, environmental footprint, all of those things. That was the basis for forming the decision for that being the preferred alternative, as well as the other features that we described. So in the end, we talked about the property, the temporary and the permanent property needs to do any improvement at Walk Bridge being similar for all the alternatives. We talked about the project limits being really consistent between the alternatives. You're not going to get away from doing work on the west end or the east end with any of the alternatives, but it's a matter of how you implement that. And really kind of what it comes down to is that construction staging and then being able to communicate those impacts that may occur during construction and any impacts that may be apparent with the environment as well. So with that, hopefully everybody's still awake. We will entertain questions.
Can you have the lights up, please? So, we're happy to take questions from all of you. If that's the case, please just raise your hand. Yes, over there.
From what I just heard, it sounds as though the high-level lift bridge is the best alternative. Is that correct?
The question was, for those of you that may not have heard it, the question was, is the vertical lift bridge that was shown as a preferred alternative the best alternative? I would say that it's the preferred alternative because it best meets the project goals. And again, one of those goals that we hear is the construction time and the construction impacts. And that alternative, from our assessment, best addresses those two elements.
And I have an
okay.
addendum to that question.
Yes.
Because in the presentation, it looked like you showed two different types of lift bridges, one 240 feet and the other 150 feet. And at the end, I wasn't sure which one was most advantageous. And why would one need a 240-foot lift bridge?
Great question. So yeah, there were two different vertical lift spans that were studied, and let's get back to both of those. So the one on the top was the 240, the span that has a 240-foot length, and what that does is that it puts the entire structure from the foundations to the towers on either side of the existing swing span. Okay. So what we're doing there is that we're not blocking any of the current channels within the waterway itself. Okay. So the shorter lift span, the 170-foot span, it has the western pier. So that pier and that pier are in the same location. Okay. With the shorter span, what we're doing is we're building a foundation right in the eastern channel of the existing swing span. And some may say, well, that's okay. And it may be okay. But there's a couple of disadvantages to doing that. One, it does shut off the channel. And what it also does is that it could potentially impact the temporary channel hydraulics, because now we have this huge obstruction right in the middle of the river, right? So with the 240-foot span, we're further out, right? And so we're not in the peak flow area of the waterway itself. The second thing is that in both of the alternatives for the lift span, this pier is built adjacent to what we call a rest pier. So when the swing span closes, the east end and the west end sit on what we call a rest pier. And on the long span, we're straddling both of the rest piers. On the shorter span, what we're doing is we're building not only close to a rest pier, but we're also building close to the existing pivot pier. And so the sensitivity to installing foundations in close proximity to that existing pivot pier, which is the middle pier that the swing span operates on, can be challenging, right? And so what we want to be able to do is we want to be able to control any construction risk that may be introduced by building in close proximity to that pivot pier. So there's a couple of reasons behind it. The other factors come into play when it comes time to talk about how do you stage it, how do you implement it in that step-by-step process. And at some point, you either have to cut out part of that swing span to get that shorter span in. But with the longer span, as I mentioned before, those engineers were clever with that 4-track swing span, but it's a big impediment. And with the longer span, you don't even have to touch it.
One quick further question.
Uh-huh.
What will be the height of clearance under the bridge with the lift span?
Right. So presently, what we have is, again, based on the guide clearances that were provided by the Coast Guard in conjunction with the navigation study, because there is a structure across Norwalk River right now that has a vertical clearance of 60 feet above mean high water, we're matching that right now. Does it have to match that in the end? That's the starting point.
What determined that height initially, the I-95 bridge height?
That's a great question. I researched that because I wanted to find the Coast Guard bridge permit for that, and I couldn't find it. And I don't know, John, if you have any background on that. No, that's a great question. I myself had the same one, and don't know what established that back in the day.
If it was determined that it no longer applies, could the towers actually be lower and the lift span raised less?
No. Well, it would be, again, part of the consultation that would be going on with the Coast Guard and the waterway users. Because, again, the Coast Guard, they want to be able to meet the reasonable needs of navigation. And if you try to find a definition for reasonable needs of navigation, you're not going to find it. Because the Coast Guard looks at it on a case-by-case basis. And sometimes it's dependent upon the number of vessels. Sometimes it's always based on the type of the vessel. But it's always handled on a case-by-case basis. So there's no definition that you can look up and say, yep, that's reasonable needs of navigation. So it's through dialogue and it's through investigations of what's been there before, what's going on now, and what may be planned in the future.
The Basco drawbridge was the original preferred bridge, replacement bridge, if I'm not mistaken. And for some reason, something over in West Norwalk eliminated it, and then you've gone to this vertical lift bridge. Now, a Basco bridge, which is essentially a drawbridge with a counterweight, is the most common bridge used for opening because it gives you quick movement up and down, low power, and unlimited vertical access underneath it. Now, if there was a problem in West Norwalk with the Basco Bridge or the drawbridge, from where it is now, was there any consideration to move the drawbridge over to the East Norwalk side channel?
Yeah. Let me answer your last question first, and then I may need some help remembering the other parts of it. But so one of the reasons why the alternative that you see at the bottom of the screen here has a counterweight on that side is that we had more space to work with, right? So in any of these alternatives, whether it's a fixed bridge or a movable span, we have twin structures side by side, and that speaks again to that operational redundancy. Because we have to have a certain amount of space in between the structures, there's more space on the east side to put the counterweights. So the wider part of the Basco Bridge is on the east side. And then as you move towards the west, then the width of the structure narrows up because you don't have the operating machinery and you're really just dealing with the width of the truss. And in fact, that track alignment was on what we called a non-parallel track alignment. So the spans themselves weren't although they were twin spans, they weren't parallel with one another, because even though we had space on the east side, we needed more space because we had to spread out the tracks in order to get those side-by-side movable spans to fit in place. So by virtue of that, that particular structure type would not work over with the span flipped around and the counterweight on the west side because we need more track space.
That isn't what I'm asking. What I'm asking is, could you have taken the Basco Bridge as we see it right now?
Yes.
And move it to the right with the counterweights on the East Norwalk side, not in the middle of the river, as you have the counterweights.
Whoops. Move it like to where the control house is?
Yes.
No, because two things. One, we would be pretty close to building a new pier, like right on top of the existing pivot pier. That's one thing. Or we would be building this pier right in the middle of the current west channel. So you've effectively cut down your waterway by trying to implement it. So if you go back to that first chart and that A through E pier placement, that option is listed in there, but it was dismissed because the deeper part of the channel is over on the west side, right? So we want to be able to have, if we're trying to accommodate navigation, we want to have that deeper channel on the west side of the channel. As you move yourself to the east, that water depth starts to get more shallow, and so you're kind of defeating the ability to accommodate navigation as you get further to the east.
What is the difference in the depth between, as it is now, the east and west channel?
Yeah, so our bathymetry, which is so we do basically it's a sonar survey of the underbottom, and at the bridge itself on the west side, it's upwards of 18 feet, maybe 20 feet in some spots. As you work your way to the east, that depth gets to 10 feet, 8 feet, and then obviously as you get even closer to the east, you're into the tidal influence, and it's whatever the tide is.
Well, those two channels have been there now for 120 years, and they've worked. They're both deep water channels for 120 years, and they both worked for 120 years. And you're saying now that the channel on the East Norwalk side could not accommodate the drawbridge?
What I'm saying is that the channel depth itself does change as you walk your way from the west side of the river to the east side of the river, as it relates to just the channel bottom, right? Because the natural flow of the river causes the west side of the channel to have a natural greater depth because of the velocities as you're coming out of the curve of the waterway. Kind of generates that on its own.
And one last question.
Sure.
Opening and closing the drawbridge, as to how long that would take, as opposed to the vertical lift,
Sure.
The 240-foot vertical lift.
It's imperceptible. The size of the motors, the size of all the machinery on all of these types of movable bridges that we're showing, with the exception of the swing span, which actually has a little bit smaller machinery, they're 75 horsepower motors, and there's two of them, and they operate the span. And we get this question a lot as it relates to the time of opening, and the time of the opening is as I mentioned, nearly the same for both alternatives. But there's a sequence of events that happens in any bridge opening in order to make that span go up and down. So and on the railroad, it's a little bit different than on a highway bridge. You have to have the trains to pass. You have to throw the signals. There's a lot of controls that kick into gear in order for the span to open. The vessel may not be there ready to go underneath the bridge. They may have called for an opening, but it may be a little ways away. So the actual time from start to finish to open and close the bridge and then get a train going again is somewhat undefined. But the actual time, if you were to push the button and have the span open and close, they're nearly the same. Probably less than a minute and a half total. Yes?
What's the elevation change on the west approach of the with the preferred alternative?
So for the question was, what's the elevation change on the west approach? Are you referring to the approach structures over the street, for example, or
At the alleyway between Ironworks and the Lock Building.
right? So right now, and I may have to call on one of my bridge engineers. What for a girder depth over the roadway? It goes from.
So is the question related to the elevation of the track or the
Yes.
clearance over the road? The elevation of the track?
Yes.
No
The
change.
preferred alternative is no change. If you remember the graphic with the grade raise and the staged construction, anything more than a couple of feet is essentially impossible to maintain 2 tracks of rail service without fouling one of the interior tracks when you're constructing the other 2.
So that elevation that you see there is the elevation that would be there with the preferred alternative. So we're not looking to make any adjustments to that. So
essentially what happens is there is a horizontal shift that starts back near the Danbury Y and gradually increases the spacing between the 2 center tracks to about an additional 12 or 13 feet by the time you get to the river. So there's 2 tracks on the left that are going to gradually move outward, but in the vicinity of the Ironworks building, they move to the south about 5 to 6 feet. Was I not audible?
yeah.
Could you guys hear me?
Yep.
I can talk loud.
Question right here.
Yeah. Is there any way to lower the level of the river through a lock?
Is there any way to lower the level of the river through a lock, was the question. Not to speak for the Army Corps of Engineers, but just knowing what I know, it would be, I would say that would be challenging, but anything's possible, right?
Well, I just visited the Erie Canal,
Uh-huh.
so I was impressed, with the technology, and it's old technology. In fact, they were saying one of the gates was Michelangelo had it on his drawing board or something like that. But, like you had one part that was completely navigable all the time, but the one seems like you only use it 2 or 3 times a week, according to the, that a vessel that needs that depth. So they can just lower it, chucks forward, comes up on the other side, and move the water back.
I'm not a hydraulic engineer, but there's obviously ramifications of doing something like that. But
But I think that somebody should say, no, that's crazy, or yes, it's possible. You're asking for options.
Sure.
Okay.
Yeah.
If somebody who doesn't know, just coming from different angles. I think it should be considered. I think you should at least ask somebody that has that expertise to see if that's possible.
Okay. Thank you. Yes.
I don't want you to feel like the only crazy person in the room. So,
Yeah.
One of the challenges of doing something along the lines of a retractable bridge, something that slides. If you went with a 170-foot configuration, you'd have enough room to hold back some kind of a structure, but also have enough room to build enough of a support structure to support the weight.
Sure. The question was, what about a retractable span? I would say that the primary challenge associated with that, which was actually a primary challenge with the rolling bascule bridge, is the overhead catenary. So not only do you have to move the span, but you have to take the overhead contact system, the electrified lines overhead, along for the ride as well. and that's.
Could they go up? I mean, do they have to, or is it, I guess but they're not being used, I mean, while the bridge is retracted.
Electrify it.
Yeah.
Electrify the track there.
Third rail.
We can do it. Third rail, we know what that is. The train does it.
Yeah.
Third rail it right through there.
Are there retractable spans?
There are retractable spans. In fact, if you want to look up Islas Creek in the San Francisco Bay Area, was proposed to be a retractable span, but it was a 50-foot span, a roadway bridge.
Was that ever a possibility of looking at third railing
John,
in
were
the
you
area so
on
that
the New Haven
we
line?
have other alternatives?
You have to remember the New Haven line is a subset of the Northeast Corridor.
I know that.
Okay, and so I can't speak to what investigations went into a third rail possibility, but there would be impacts kind of up and down the line as it relates to the train sets and things of that nature with a different type of power system.
They all do third rail.
Chris, Amtrak doesn't. We did kick that idea around, even for temporary. But like on the runaround, Amtrak doesn't have third rail capability, but all of Metro North trains do. So it would eliminate Amtrak service.
Could you explain how the runaround is not required on this preferred alternative? Why?
Yeah, that's a great question. All right, one of the whys. So the runaround, let me go to a picture of the runaround.
What was the question?
So the question was, why does the preferred alternative not require the runaround? So let's go to a picture of what the runaround looks like. Okay. So the runaround was investigated as a means of doing work in the vicinity of where the existing bridge is, while still being able to accommodate rail traffic. Okay, and so we have four tracks out there now, and the runaround structure would be a 2-track structure. And because of the constraints with the site itself, so the end of the bridge is to the west of North Water Street, and the Aquarium is the limiting factor, well, one of the limiting factors on our ability to completely bypass the entire bridge. Okay, so this gets back to our ability to get away from the operating tracks as much as we can. And with the smaller spans, like the mid-level fixed bridge and the low-level fixed bridge, the configuration of the foundations themselves is such that we're in close proximity to the operating tracks. Okay? With the vertical lift span, what we have is that we're placing the foundations outboard or outside of the width of the existing structure and far enough away to the point where they're not affecting the tracks. So in the critical area over the waterway, where the runaround is and where the lift span is, we actually have foundations that are wider than the existing structure, much wider than the existing structure. And then doing work in those areas gets us away from the operating tracks. So we're able to complete that foundation work without significant impacts to the railroad operations. So we're putting piers over in this area. Basically where there's a pier there for the runaround, there's a new pier for the big bridge. And then also in this area, we're far enough away from the operating tracks in order to accommodate the construction of the bridge. Now, the runaround, as I mentioned, it doesn't do you any good with what's going on over here. In fact, putting in the runaround takes a lot of prep work and all of that to actually get it to tie in to the existing bridge. So you're actually doubling the impacts over North Water Street by putting in the runaround. Something to keep in mind as it relates to how that actually gets implemented. Did that answer your question?
No. So my question is, why don't you need it to build the lift bridge?
Right.
Explain that the bridges get built off-site and lifted in, right, so that you can just do that in a quick period of time? The transition. As opposed to a long.
Yeah. So one of the accelerated bridge techniques that we're going to implement on the project, and really in any of the alternatives, is that accelerated bridge technique where we're going to pre-assemble elements of the bridge and have them ready to be installed. But the primary factor as it relates to the preferred alternative is that the foundation width is such that we're far enough away from the operating railroad because we have these towers that straddle the existing bridge, that we're far enough away from the railroad that we don't need the runaround to build those foundations. We don't need the runaround to erect the tower. Meanwhile, off-site but close by, the new span is fully assembled. So when it comes time to install it, it's sitting there ready to go and able to set into place. So the runaround, I got all these slides I need to, sorry. If you go back to the runaround, again, the runaround focuses on the work over the waterway, right? So over the waterway, we're building a new foundation way out here, and we're building a foundation way out here, far away from the operating tracks. So we don't need the runaround. It doesn't do us any good because we can keep trains moving while we're doing construction activity underneath on the foundations, and then as we're building the lift span towers, we're also far away from the tracks. So the runaround itself, for all intents and purposes, ends right here. But the lift span's out here, so we don't need it. But on the smaller bridges, where we have more reasonably sized foundations for its structure type, we're building real close to the existing structure. And so the runaround itself, because we don't want to be building piers right here and right here while we're still trying to operate the trains, because that imposes a huge construction risk. The existing piers could be susceptible to settlement or any other factor while those foundations are being built. So the runaround gets you away from the existing bridge. But we're already away from the existing bridge with the preferred alternative.
How long will the railroad be out of operation while you're removing the old bridge and sliding the new bridge into place?
How long will the railroad be out of operation while the existing bridge is removed and the new bridge is installed? That is a question that hasn't been answered yet. And there are a couple of concepts that are under development that need a lot of coordination with Metro North in order to get their approval of a construction scheme. So one thing that we didn't mention here today is that the project is being delivered via the CMGC method. That's Construction Manager General Contractor. So there's a contractor that's part of the team right now that has a lot of experience in building these types of bridges. So we collaborate with them on a daily basis. We, as the commissioner mentioned, we have an office in Norwalk. We have a design office in New Haven. And our design team and the contractor are there daily. And so we work out all these constructability issues together from a design perspective and from a construction perspective. Metro North is in our office maybe 2 to 3 times a week to talk about these things also. So one scheme is to have a brief shutdown of the railroad. And by brief, I would say in the 96 to 120 hour time frame in order to make that switch out of the spans. For example, Amtrak's Thames River Bridge in New London had a 96-hour shutdown of the Northeast Corridor to accommodate the new lift span there. Alternatively, there's investigation underway right now to not have any track outage of the railroad to accommodate the installation of half the bridge. So when we implement a new bridge, whether it's fixed or whether it is a movable span, we will take the railroad down to 2 tracks for a period of time, and we'll build half of the bridge at a time. And again, that 4-track swing span is the big impediment to doing that unless you have that really long lift span that straddles it. And that makes that concept that much more simplified. So to answer your question, the timeframes that we're currently looking at range from 96 to 120 hours to technically 0, but while they're doing that installation, they will likely have a brief closure of the railroad, but not to be significant. Yes?
To that, pardon me, to that point, how would you do that? I mean, would you split the existing swing span and drop in half 2 tracks and then take out, how does that work?
Yeah, so in the scenario where you would have the total shutdown of the railroad, let's say, for that period of time, basically what happens is barges get positioned under the swing span and it's floated northward. Right behind it is the vertical lift span that is floated into position and set on rails and then slid into place. And I think one thing that would benefit everybody, I think, is eventually we could probably post some of our 3D imagery that shows this, coupled with real live action video of where this has been done before. So this is a really common accelerated bridge construction technique on railroad projects where keeping trains running is paramount because there are no detours, right? So you have to think about how these things get built, and that really informs a lot of our decisions. So to answer your question about how would you do it without fully removing the swing span, you would have to partially disassemble the swing span. So when you do that, that would introduce a channel closure in addition to, so that's kind of the trade-off, right? So you have no channel closure, brief railroad outage, or you have a channel closure with no railroad outage, and those are the 2 scenarios that are essentially being evaluated presently. And then you have to look at, well, how does the existing structure behave when you take half of it off? Again, it's been sitting there relatively happy for a long time, and then when you start making adjustments to it, that's when you start to introduce risk, and you have to really fully understand what potential ramifications could result from that type of operation. Yes?
You did a wonderful job from where you started. But I have a 2-part question. The first part is, who made the initial determination to change the bridge that's there for a new bridge?
John, do you want to answer the background on how that came about?
So I don't fully understand your question.
Who made the determination to put a new bridge there? This is a $1 billion project. Who made the determination?
Well, right now, based on the need to maintain the Northeast Corridor, and through our analysis that we just completed here, the preferred option is to do a replacement.
No one gave you the go-ahead. You just went ahead and did this on your own, is what you're telling us?
No, we're doing it as a department. The department.
Who told the department to go ahead and change the bridge and spend $1 billion?
Well, we're in the process of making that determination right now.
Who told you to do it? Did this come from the governor's office? Did this come from federal authorities? Who told you to go ahead and do this? Or are you on a frolic of your own?
No, I would say that it's the department's decision in conjunction with the other stakeholders.
Why does the river have to remain navigable? Now hold it for a second. Let me just tell you as a background for myself. When I left law school, I worked for the senior senator from Florida. I worked frequently with the Coast Guard on navigable rivers in Florida. And there were times that those rivers were declared non-navigable. In your presentation tonight, you talked about reasons for keeping the river navigable. You had a list. I could read 6 of them that were rowing clubs to justify having a lift bridge there. The other was you talked about past uses for the river that might become uses in the future. Now, I live at the corner of Ann and North Water Street on the top floor apartment. I have probably the best view of the bridge of anyone in the city of Norwalk. I see the amount of times that it's open and the amount of times that there's no need for it to be open, but it still opens. On top of that, I have a perfect view for the old piers that are on the east side of the river that have fallen into the river and will never be used again. What's the justification for this amount of inconvenience for the people of Norwalk and for this expense for the state of Connecticut for keeping this river navigable? Who's justified keeping this river navigable?
You want to answer that one, Chris? You just went through that presentation.
Yeah. Well, let me just start off by saying, hopefully we would all agree that something has to be done to the existing bridge, right?
Only if it needs to be opened.
Well,
it gets stuck when it's open.
It's got to be rebuilt no matter what.
I mean, if you look at if you go back to the Rehab Alternative, right? So if we were just to walk away from the bridge, something would have to be done to it, right?
That wasn't my question.
But what I'm trying to get to your answer.
You're jumping to the conclusion that the river has to be maintained as navigable.
No. Let's take that off the table. Let's say, for instance, that we threw all the regulatory requirements and the upstream users and the potential development off the table, right? And let's just look at the bridge. So we have, again, the number of trains a day seems to fluctuate, and I keep using 150 trains a day, right? So there's 150 trains a day that go across the Norwalk River. Those 125,000 passengers a day have to get somewhere, right? So they need a bridge, right? So we have a bridge that's 120 years old, and it does, by happenstance, operate and it accommodates navigation. If you just took a look at the bridge itself, and you took a look at the structure of the bridge itself, and the fact that it's been out there for 120 years, and I mentioned that, again, we're literally in uncharted waters for a bridge that's that old that sees that much volume of traffic, okay? So when you take a look at the image here, if you were to take away the navigability of the waterway, and you would still have to have a bridge. You would agree with that, right?
I want that bridge to be safe. You're absolutely right.
Yep. So, because of that, then, if you wanted to go with the rehabilitation option, then you could do that. And you could do that, and again, I'm saying this on the premise that we're discounting the regulatory stuff. So you could do that, right? You could repair the bridge. Repairing the bridge and taking a look at the number of elements of the bridge that are currently insufficient by today's standards is voluminous. And if you take a look at the image here, the yellow highlighted members of one plane of the truss indicate those members that have to have significant strengthening done to them or even replacement of those members. Okay? So what we've done is that we've quantified what those needs are. So we know that a particular member needs to have something done to it. So there's a particular level of effort required to make that improvement. Okay? So whether you have a waterway or not, you still have to do something to the bridge. And this, I think, gets back to some comments that we hear that let's just fix the bridge, meaning not rehab it, but make it stationary and walk away. Well, that actually doesn't meet the needs of the project, because right now there are a lot of needs on the bridge itself. It has to be improved from a capacity standpoint. All right, so we have this century-old bridge, and we're trying to match it with modern rail systems. They don't jive. For example, we want to have continuously welded rail on the bridge, okay? And in the 1890s, they didn't have trains that operate the way they do now. They don't stop as quickly. They don't accelerate as fast. They have different rail systems. From a maintenance perspective, the railroads, they want to have this CWR, continuously welded rail. This bridge wasn't designed for that. By having those modern rail systems, you're cutting down on downtime. You're cutting down on maintenance just to actually run your trains. Not to mention the fact that the loads that you're trying to carry on the bridge are such that there needs to be improvement made to this, okay? So if you go back to that image that shows the limits of the project, just fixing the bridge, repairing a stationary bridge is a huge undertaking. And it's huge because it's system-wide. The high towers do need to be strengthened. And you may ask, well, why do we care about the high towers? Well, the high towers actually carry Metro-North elements on the high towers themselves. So they're pretty critical to the ability to run trains. The bridge structural elements, the superstructure, the steel, needs to be repaired. Okay? And those areas are highlighted in the yellow there. The bridge foundations need to be strengthened as well. Some would say they need to be stabilized.
I don't want to keep.
I know, but what I'm saying is that's not easy to do.
If you go with the simplest solution versus the most complicated solution, which is the most expensive solution you're going with, there's a huge amount of money to be saved.
Well, one could argue that the rehab is actually the most complicated of the alternatives.
Well, what about no navigation and a fixed bridge? Not worrying about traffic going under the bridge. What would that cost be? Has that been looked at?
Yeah, this is what I'm going. This is what I'm talking about.
What is the cost again?
The cost of the rehab that we have is, what is it? It's right around $400 million. And I know that's hard for people to understand, but again, it comes down to you're working right on top of the bridge, and you've got 150 trains going over your head every day. So your ability to do that work is limited literally to an hour and a half, 2 hours at night.
You can close two sides and have it go to the other side. You can do a single lane in each direction. That's not that complicated for you to do. You're making it more complicated than it needs to be. What's the cost of the least expensive bridge versus the most expensive
I'm not
bridge?
making it more complicated. There are railroad work rules that are mandated by Metro-North and the Federal Railroad Administration that makes this more complicated than on the surface it would appear to be. So the cost of making the machinery costs for the swing span alternative, if we were to do the rehab and we were to upgrade all the mechanical and the electrical system on it, is 5 to 10% of that $400 million cost. So if we take the existing bridge and we go to repair it and we keep it fixed, we don't allow it to move, of that 400 and some odd million, you're going to cut back about 5 to 10% of that cost. The mechanical and the electrical costs isn't the primary concern. It is in terms of it operating and accommodating navigation, but in terms of safely accommodating rail traffic, it's from end to end. It's everything that you see from here to there. That's where the cost comes in. So it's a huge effort. Yeah.
I'd like to add something.
Sure.
Because you're doing such a great job here. I think we are.
Yeah.
So the differential, which is what he's talking about, is 10 to 15%, and then if you then try to account for the navigation losses in terms of impact to commerce, the economic value of that, we haven't even calculated that. So that would from our perspective, put that cost over the cost of, let's go back to the bridge, our preferred alternative at the moment. Don't mix and match the two costs. The bridge construction cost is not $1 billion. There's a set of programmed investments that would get done in this corridor no matter what, that would get added to the replacement or the rehabilitation bridge as well, right? Because we still have to do the local bridges that are beyond their useful life that will be done as part of this. We would still be doing the dockyard project. And so the program is larger than the bridge. If you go back to just the bridge, look at keep it the way it is and rehabilitate it versus our preferred alternative. Then add in the loss to the economic value of navigation.
Excuse me,
the
what
cost differential.
Loss to the economic value of navigation? Please be more specific.
Well, so the costs for the shippers that are there, to the commercial vehicles, to the recreational vehicles that would be lost because the bridge does not open again, has not been accounted for in what the ultimate cost of the project would be. And a final piece of this is that the cost to Connecticut taxpayers from a state perspective is not the full cost. We have federal partners that have contributed Sandy money. This is for the resiliency of this bridge because of its criticality. And so our cost is not the full amount, and in fact the total is likely to be more like 80% federal and 20% state. So
it's still wasting money.
Well,
it's still money that's being wasted on something that doesn't need to be done the way you're moving
I think we
forward.
beg to differ, and that's why we're going through the alternatives, because if you add
Tell
up the full
that
cost.
to the owners of the property that will lose their business because you won't be able to navigate.
How many properties are there?
Not only that, but how about the value of the properties up and down the river afterwards? The tax.
Right. So we're not prepared to comment on that tonight in terms of a quantification, but that's a real cost that if you were to do full cost to full cost, a navigable waterway does not have that impact. It maintains that, in fact, sustains the operation and enhances it. Yes.
Here?
Yeah.
Hi, thanks. So along these same lines, actually, you had a slide up earlier that showed the number of times the bridge has to open. And I think it was the 2015 number was 150 times in the whole year.
Right.
So we're talking about, like 2 to 3 times a week, maybe.
Yeah.
And so do you know the ratio of commercial to recreational openings within that 150? What the mix is?
It's in your pie chart.
Yeah. Yeah.
That's part one.
Sure. Do you want to go to part two, or do you want me to answer part one?
And then in that too, then the slide you had up with the 25 water-dependent uses, how many of those are north of the bridge? In other words, dependent on access underneath the bridge.
Sure. So how about I answer your second part first? So if you go back to this graphic here that it's on a board in the lobby as well. Let me go to Yeah. So all the ones that are listed there are the ones that are north. So it's the
So, and I just want to clarify, because I don't know if it's a matter of semantics. You have it as waterway users. Does that mean that they are that they're dependent on getting underneath that bridge?
they have access to the waterfront. Is the listing
Do you
there?
know how many of those are dependent on the height of being able to get under the bridge for recreational or commercial?
The specific entities. Let's go back to the.
Is it maybe 3? I think it's 3.
This one here. That was the slide that you referred to. So one thing to keep in mind here was that in 2014, that was when the well-publicized issues with the bridge started, right? So the bridge was not as free to open and close as it once was because of the restrictions that were placed on it from the Coast Guard, right? So a lot of times then, when there was a bridge opening, there would be multiple vessels that would pass because they would know when that opening was, and they'd be able to capitalize on that. So the numbers that we see in this 3-year trend here have gone down because of that restriction. So it's not a real reflection of the number of vessels that go through the that go through.
Well, the
so,
users accommodated that. I don't think. Are you saying that companies went out of business then, and that's why?
No, I'm not saying that. No.
So they've accommodated the fact.
No.
That
So rather than one.
Adjusted.
Rather than one boat equal one opening,
right.
It may be 2 boats equal one opening. That type of thing.
So it would be more of an adjustment in the schedule. So just back to my other question for a minute, though. 150. Do you know the mix between commercial and recreational?
Yeah, I can give you a snapshot here, just of 1 year. That was on the mid-level lift, right? So, and just as a note, in the mind of the Coast Guard, they view recreation as commercial because they had to buy a boat, they have to buy gas, they're going somewhere to buy something. So whether it's commercial in terms of whether you're shipping a commodity or whether you have a sailboat that you like to go out on the Long Island Sound in, that the Coast Guard views that as commercial, and that's in their documents. And I'd be happy to share that with you. So the designation of somebody with a sailboat versus somebody with a tug and a barge, in the Coast Guard's eyes, they don't care because it's all how these Coast Guard rules started was for commerce, right? The preservation of commerce, because the water was there first, right? Then all of a sudden we started to have trains, and then we had cars, and people wanted to get across the water, but the Coast Guard and the Army Corps at the time, back in the Rivers and Harbors Act of 1899, said, well, we want to make sure that we can still keep the waterways going, but we still want to keep the surface transportation going too. So in their mind, whether you have a sailboat, like I said, or you have a barge, it's all commercial and it's all commerce related. So let me get to your question.
I just think the fact that you don't have that definition, I understand that there's no definition of the reasonable.
But I would say, excuse me, I would say that 80% of, or 90% of the pleasure boats that are going through to go to a marina that has, it's a boatyard, and it's got, it's a commercial facility.
So the other part of my question, though, has to do with the cost that I don't think you've addressed. So if you have the bridge going up and down to accommodate whatever level that is, 150 times, and I think some of that might be seasonal as well. So we're looking at
right. There are some seasonal
use, so it's actually compressed. So we're talking about stakeholders, 175 trains a day and 125,000 passengers versus this compressed seasonal time of year and very limited scope of stakeholders. But I want to understand what the costs are associated with having the moving bridge going forward. There must be some person, I think, that is responsible for raising the lift. And then there's also ongoing maintenance costs. Are those completely nominal, or what are the costs of that annually?
Sure. So with any bridge of any type, fixed or movable, you have an operating cost associated with that asset because there's inspection programs that go on. There's things that may break on it that need to be repaired, right? So every asset has an associated operating cost with it. And so what has been done with all the alternatives, that over a 100-year life of the structure, each of those years, there's a predicted cost associated with that, whether it's year 1, you're only doing an inspection. Year 2, you're doing an inspection, and then you're doing a different type of inspection. As you get into year 5 and 10 and 20, you're starting to do maybe some minor repairs. And then as you get into the later stages of the structure's life, just because of wear and tear, you may have a more robust rehabilitation or repair effort. So all of those on a 100-year life cycle are quantified, and then there's a cost of money associated with that and an inflation rate associated with it, and so they're annualized in terms of present value, right? So at the end of the day, a bridge may have an operating cost of, let's say, $100 million. But then annualized, what the investment is for that particular asset is based on the structure type. So for a movable span, you do have other elements that need maintenance, like your car, right? So through routine maintenance and a designated maintenance protocol, those maintenance costs can go down. So what we've seen over time is that the bridges that function well, the movable bridges that function well, and that are advanced in their years, those have been the ones that have had a dedicated maintenance program that gets attention routinely, right? It's the structures that that have maybe had some deferred maintenance because of maybe some other priorities, and then you're in a position where some more robust efforts need to take place. So as part of a new movable span, there's the development of what we call an operation and maintenance manual. And what that does is that it gives the owner a step-by-step manual on how to care for this, just like you'd have an owner's manual for your car, when to change the oil, when to rotate the tires. So if that's...
Yeah, are you suggesting that it actually costs less in the long term?
No.
No. So, without being able to give you a precise answer, because we don't have it at our fingertips, in the report that was done about the bridge options, there is a life cycle cost that includes the capital plus operating and maintenance. And the movable bridge is more because we are building this with an operator attending it, so you have to add the labor cost in. A rehabilitated bridge is going to cost more as a maintenance matter, but there's an operating cost with the movable bridge. But without it, you forego the maritime functions because you shut down the bridge. So in that regard, we're still valuing that as a priority for the project, and without it, we don't meet, as we've defined it, the purpose and need. But to your point, it is more expensive to have the movable bridge on the life cycle cost.
Okay. And I just want to understand what those dollars are.
Yeah, and we can provide that in some fashion through this. Maybe we'll post that in the Q's and A's on our website. After this meeting, we can put it up as a Q&A so you can look at that on our website.
And they are in the environmental document, and I apologize that I don't have the exact numbers that I can cite for you, but they are in the document, and we can share how those are developed if that's if additional information is needed. Question right here.
Regarding the operating cost, how is the project looking forward to coordinating control of the walk bridge with the Stroffolino bridge?
John, can you answer that? How Stroffolino and
yeah, right now that is being done by with the Coast Guard, with the Office of Rail, and it'll continue to be coordinated.
Is it possible that one operator could do two bridges at once?
We have not looked at that, but we could look into that. I'm not sure right now. They're two separate bridges. I'm not sure they'll allow the same operator for two separate bridges. I mean, the control house is in both. The existing Stroffolino has its own controls, so you probably would have to have two operators, but that's not been studied right now.
So the myriad maritime users, you need two phone calls to come up the river?
Currently, they might be able to coordinate between each other. I don't know how it's done right now. Does anybody,
I can answer that because I go up the river.
Yeah.
Stroffolino is just by radio, so you call when you're ready to go, and they open on demand, and they have limited times during the day or rush hour when they try not to. The bridge you call in advance, and they like it to be a day before, but it can be shorter to Metro North or the main group, and they will give you an opening time that will fit between the trains.
Okay, thanks. In the back?
How do these designs accommodate the Harbor Loop Trail and the Norwalk, the River Valley Trails?
Right now, we have a study out there looking at the need for both of those trails, and we're trying to see, incorporating those into the project.
Well, I sure hope you do.
Yeah, the question was the Harbor Loop trails that are out there. Right now, we have a study for both trails to be installed under the project. Question right here.
Yeah, I have a question that's a little bit, that broadens the perspective a little bit, I think. You're talking about the navigable water and the need for improved rail service. But in this area, especially in Norwalk, there's a lot of concern about truck traffic, for instance, congestion problems of a major level.
Margin product up the river is equivalent to same truckloads or product up the river.
And that's of every kind of product?
Stone or sand.
Yeah, so, it seems to me that if that river is kept navigable, that's an incentive, perhaps, for some companies that haul materials like that to try to locate on the river. We had O&G and Divine. King Industries was very interested in having that river navigable, and I think that the communities could maybe have some influence in trying to get certain kinds of traffic, truck traffic, off the road if possible, where barges or other vessels could help the issue.
Yeah, thanks for the comment. It is why the commercial piece of the waterway is important, and it is a key feature and mission of the Connecticut Port Authority, newly established, to look at all waterways, not just the deep water ports. Norwalk is one of the major ones in terms of its economic impact and value. And I do think that the future of dredging resources, particularly from the Army Corps, is dependent on continuing the definition of this as a navigable waterway, or that could be foregone, so it actually could worsen conditions. So the long-term future of this as a maritime, hub would be critical to keep it as a navigable waterway.
Yes, sir. I just want to make a statement to what you just said. To get the material up the river, it can be done with a fixed bridge. I don't want to go any further than that. What you're saying, you're kind of putting fear into these people. It can be done with a low-profile tug up and down that river for the next 200 years without ever being dredged again. Now, you're looking at me. You should tell the truth to these people that it can be done right the way it is now with a fixed bridge. So you saying that, it may have to be dredged, it's not so. I just want to go on record.
I appreciate that, and I'm not saying it has to be done now.
No,
what I said was the eligibility for dredging.
Yes.
Right, and for Army Corps participation.
It's never going to be dredged again. You know it, and I know it. You'll never be dredged again.
Oh, yes, it will.
I don't know that that'd be a fact, but I appreciate the comment that certain activities can be done with low-profile vessels.
Bunch of phonies.
Can I put that in the form of a question too, though? And this may sound dumb, but I want to understand this because I've heard this before. What is the height of a barge? I don't really know what a barge is. And can the barge itself, what you're calling the barge, does that fit under the fixed bridge, under the height of the bridge now? Versus whatever the vessel is that moves the barge.
Yeah.
I guess a tugboat.
Mm-hmm.
Yeah.
So
that picture there of that tug, and let's focus on the tug, because the tug is the controlling vessel in terms of the clearance. Right.
So couldn't you have, so the barge fits, correct? Whatever a barge is fits. Couldn't you have a push and a pull, like you have a tug on one side of the bridge that pushes, and then the tug picks it up on the other side? I mean, and again, I know it may be a silly question to people that understand these businesses, but I want to understand.
It's an interesting question, but you really don't want to let the barge piece of this loose in the middle. We've got a channel that has a flow to it, and you really want to keep that connected from a safety perspective. One of the benefits of the longer bridge is a wider opening and a more centralized channel that meets up with the Streffolino Bridge to make through movements easier. So it actually will open up, I think, navigability and safety for that reason. But you wouldn't want to separate the tug from a barge, let it float, if you will, and pick it up again.
No, and that's fair. I didn't envision that it would be that big of a span before it connected with whatever was on the other side of the bridge. But then to this, what Mr. Penn was just saying is there a low-rise tug that meets the criteria?
So there are tugs today that do not, and that's why the bridge opens. Conceivably, are there tugs that could do a function? I guess there are. It's not today's operation.
Okay, but they exist.
I'm not an expert. I couldn't tell you that.
I just wanted to make a comment. There's also the fact about all the condos and the housing that is upriver that have dock spaces for people with recreational boats. And if you've got a sailboat, you need that 60-foot lift. And so you're going to be devaluing the property of those condominiums with the dock spaces if people can't take boats up there to use recreationally because there's not a lift bridge. That's beside, in addition to the people like Divine and the other people that have the barges coming up. It's not just the barges. It's also the recreational boats. And I've sat between the two bridges waiting for one to open so we can get through. But it's valuable to the recreational use of the river. And I tell this to everybody I talk to, that we live in a vacation destination here in Norwalk. We have the beauty of the water, the trees, the woods, the hiking areas, and if we cut off the use of the navigational river is a terrible mistake for the full realm of the possibilities of living in our wonderful city of Norwalk.
I agree.
Thank you.
I applaud that.
I have one question. If we go with the large lifting bridge, do we anticipate like one of the Tappan-Zee type cranes on the barge coming up the river to lift these huge spans in place? Or how are we, doing a land-based crane and a water-based crane?
Right. So, again, by virtue of the delivery method, meaning the CMGC method, where we're partnered up with a contractor right now, is that we have knowledge of their means and methods, the type of equipment that they'll have, and they will have cranes that are on the water as well as cranes on the land. They're not going to be the cranes that pick up and set the span into place. The Norwalk River just doesn't have the size to accommodate a crane of that size on the water itself. So again, the common method for installation of a span like that is to pre-assemble it on barges close by and then float it into position to be set. I thought I had a picture that I may have glossed over very early on, about 2 hours ago. Actually, it was Amtrak's Thames River Bridge being erected by the same contractor, designed by same designer, basically. There's a couple shots here. There's two different ones. One's of a bascule. So that's a bascule sitting on a barge, and then that's a lift span sitting on a barge and floated into position. So you just can't lift that span, particularly on the Norwalk River. It's just not big enough to accommodate a crane that size.
So I just want to, logistically, we have the venue until 9 o'clock, and it's like 10 after 9, so if we'd wrap it up if there's any final questions.
Excuse me. Excellent job. Well prepared. And the DOT has constraints that they have to run their projects by. Okay. I am for this preferred alternative because, according to what I understand, when you build this 240-foot long vertical lift bridge, it's going to be as far away from the existing bridge. So if any kind of machinery that has to get as far away from the bridge as possible is an excellent idea, because there's a possibility while you're building this bridge that the current bridge could suffer a disruption like it has in the hot weather. You have 125,000 passengers. I remember it well when they came from South Norwalk, walking over the Stromboli Bridge to East Norwalk. Now, if we want to have that kind of publicity, and we want to have people almost at a riot stage, I'm telling you, it's not going to be good for the image of Norwalk. So, you have constraints from the Coast Guard, and the downside of this is that you're going to have these high rate commuters. So, with all this knowledge, all this investigation, talking between engineers, you are bridge engineers. You understand what goes into this whole process. Yes, we have questions, but this presentation has answered them. At least in my estimation, maybe it wasn't, I had talked to somebody at DOT, and they explained it to me in simple terms, and it made sense. So, I condemn you, not condemn you, I condemn you.
Sorry.
For coming out tonight, for answering all the questions that we've had, because an education is the best knowledge. Thank you very much. So much.
Well said.
So thank you for that. I couldn't have closed better, but I wanted to thank the audience, for those that are still here. It was an opportunity. I thank you for your patience and your willingness to participate in this. Officially, the comment period on the environmental document is December 9th. Continue to comment as you will. And look at our website, because we'll be continuing to update questions and answers and similar and future presentations. We're hoping to do those by video so that others can see them as well. But again, thank you for your participation tonight. Appreciate it.